Hi everyone. So today we will be talking about the Raoult's law, second part. As we discussed one part earlier, in which we were taking the solute, which was a non-volatile one, and the solvent was volatile, right? So there we have seen that the volatile component was only one part, which was the solvent, and the solute was not adding up to the water vapor pressure above the liquid, right? But this time we will discuss about two liquids in which both of them are volatile. Two components are there to form a solution. One is solute and one is solvent. Both of them are adding up to the vapor pressure above the liquid. Right? So this is again a part of Raoult's law. Let's take it. Let's see. This is the volume. This is a container. I've taken this much volume of the solvent. I will represent the solvent as A. And to that I'm adding the solvent. Let's say this is the solvent. This this is the solvent we've already taken, so this is solute. Okay, and now we all know that both of them, because they both are volatile, so both of them are going to add to the vapor pressure above this liquid. So if we talk about pressure because of the solvent A is directly proportional to the mole fraction of A, right? That is the solvent. So this is the first one. And for B, if we talk about like the solute, so the vapor pressure because of the solute will be also directly proportional to the mole fraction of that solute present inside the solution, right? So this is the second equation. So if I properly write this, I can write it PA is equals to PA naught. That means if only solvent is there, then what will be the pressure if no solute is there? So that is represented by PA naught XA. That is the mole fraction. I always say it as XA. Now, if I write the second one, it will be PB naught, mole fraction of B, right? And now you all know that P total will be because of pressure of A, partial pressure because of this solute and the solvent. That means you have to add both of them. So you will get PA naught, mole fraction of A plus PB naught, mole fraction of B. And you all know that mole fraction of A plus mole fraction of B is equals to 1. You know that mole fraction cannot be more than 1. Right, so let me take XA is equal to 1 minus XB. So if I say that solvent, the solvent is this. So that means the remaining part will be the solute, right? So in this equation, I will be replacing the mole fraction value by 1 minus mole fraction of B, right? So just put the values. You'll get it. PA naught. I've replaced this by 1 minus mole fraction of B plus PB naught mole fraction because of B, right? And just multiply this value inside, you'll get PA naught minus PA naught mole fraction of B plus PB naught mole fraction of B, right? And now just take the common things out and you will get the equation like this. Let's take XB out and it will become PB naught minus X pressure because of A, right? This. So this is the equation what we are getting for P total, right? Now, if I compare this equation with the straight line equation, you all know that it will become this. Okay, I'll change the color so that you can see. So this will be Y is equals to mx plus c. This is an equation, right? The equation is Y is equals to mx plus c. So accordingly, I've changed my equation because you know that this is the thing which I will be representing on the x-axis. This is the thing which I'll be representing on the y-axis, right? Now, I'll just rub this part so that you all can see the graph. Now, this is our graph which we are going to get. This is the y-axis, right? This is the x-axis. Now, from this you can see on the y-axis we have to show the pressure, right? So this is the partial pressure axis. And if we talk about this x-axis, it is going to represent the mole fraction of B, because you can see it is written already. Mole fraction of B is represented on the x-axis, right? And now, because in this line, intercept is also there, that means the line is not going to start from here. This time, the line will start a little above. So this part, this much, it is the intercept, right? So this is PA naught. The pressure because of the solvent alone, right? And if I just draw it like this, you all can get the theta value, right? which is equal to m. You know that tan theta is equals to m, which is the slope. So slope here is, I'll write it here. So the slope for this line is PB naught minus PA naught, right? So this is all about the two volatile liquids. If you're mixing them, how the partial pressure is going to be affected. The slope is telling us that, right? And we will be discussing one more part that is also related to Raoult's law, in which we will be talking about the Dalton's law and the Raoult's law. I will combine both the laws and then we will discuss. This we have discussed that how much is the mole fraction present inside the solution which is affecting the partial pressure above it. But in the next part, where we will discuss about the Dalton's law combined with the Raoult's law, there we will discuss what is the mole fraction of the solvent and solute present above the lake. Okay, so keep waiting for that video. I hope you all have enjoyed this part and the Henry's law also and the first part of Raoult's law also. So please make sure that you all like, share and subscribe to my channel for more updates. Till then, take care. Bye-bye all of you.